mass and takes up space. Examples are fruit, softballs, tools, animals, rain, flowers, and even air. So mass is how much of something you have. What is matter? Well, matter is anything that has mass and takes up space. Examples would be fruit, softballs, tools, animals, rain, flowers, and even air. Mass is how much of something you have. So the study of the properties of matter and how matter changes is called chemistry. Matter has a variety of characteristics or properties that can differ. They fall into two different groups used to identify, describe, and classify matter. And those two are physical and chemical. A single kind of matter that has distinct physical and chemical properties is called a substance. A substance can be an element, a compound, or a mixture. So, physical properties can be observed without changing the substance into something else. For example, the odor of something, how something tastes, its hardness or texture, the color of something, temperature at which a solid melts or liquid boils, and whether it's a solid, liquid, or gas. Chemical properties are observed when a substance interacts with another substance. For example, burning or flammability would be a chemical property, rusting, tarnishing, whether an object will explode. A lot of times you'll see the word reacts. So, what is an example of a physical property of a candle? And what is a chemical property of a candle? There are two types of changes that matter undergoes. They either change physically or chemically. A physical change is a change that alters the form or appearance of a material, but does not make the material into another substance. Some examples would be chopping wood, bending a copper wire, molding clay. And matter has three principal states. It's either going to be a solid, a liquid, or a gas. A change in state is an example of a physical change. And the reason that is because that particular substance does not undergo a change in its substance chemically. It's still, for example, ice water, when it melts, is still water. It's just in a liquid form. So why is a change in state considered to be a physical change? A chemical change or reaction is a change in matter that produces new substances with properties different from the original substance. Elements may combine to form a compound, or compounds may be broken down into elements. Examples of a chemical change would be souring milk, burning wood. Energy is always involved when a chemical or physical change to matter occurs. Think of tearing a sheet of aluminum foil in half, and then tearing the halves into quarters, and so on. Could you keep tearing forever, producing smaller and smaller pieces, or would you eventually reach the smallest possible piece? We're going to get into a little bit of the history of the atom, and way back in over 400 BC, a Greek philosopher named Democritus thought that you could cut matter into smaller and smaller pieces until you eventually got to its smallest piece. And he called this smallest piece atomos, which means uncuttable. This is where the word atom comes from, which is the smallest particle of an element. In 1802, John Dalton, who was a British school teacher, proposed an atomic theory. And the reason it was the first atomic theory was because he actually ran experiments on substances. And his conclusions were that atoms cannot be broken into smaller pieces. In any element, all of the atoms are exactly alike. Atoms of different elements are different. Atoms of two or more elements can combine to form compounds. Atoms of each compound have a unique mass, and the masses of the elements in a compound are always in constant ratio. Today, scientists have identified some important exceptions to Dalton's statements, but his ideas still form the basis of our understanding of atoms. So, what were two of Dalton's ideas about atoms? Now, although atoms are extremely small, they are made up of even smaller parts. There's a nucleus that contains the protons and neutrons, and then there are electrons. The nucleus is the tiny central core of the atom, and you'll find the protons and neutrons occupied there. Protons have a positive electric charge, and neutrons have no charge. They're neutral. Electrons are very energetic particles that move in the space around the nucleus and carry a negative charge. All atoms of a particular element have the same number of protons. Because the number of protons is unique to each element, this number is called the element's atomic number. So, for example, the atoms that make up the element carbon all have 6 protons, so the atomic number for carbon is 6. The force that holds two atoms together is a chemical bond. Two or more atoms that are bonded together form a molecule. Some are made up of only one type of atom, but most are made up of two or more different types of atoms bonded together. Well, scientists can't study atoms by looking at them. They're really just too small to see. So, how do they study them? Well, they make inferences about them based on observations, and they use models to make and test their predictions. How are atoms and molecules related? Molecules have two or more atoms chemically combined. Compounds of two or more different elements chemically combined. During the California gold rush, miners needed a way to remove gold from a mixture that also contained dirt and sand. Gold can be separated from other materials in a mixture because of its density. It has a higher density than most other materials, including fool's gold. They use the method of panning, using a shallow pan in water. Because gold is more dense, it stays in the bottom of the pan when the less dense materials like water, dirt, and sand are poured off. Checkpoint. How could you tell the difference between fool's gold and real gold?